Hello, my name is Lori. I'm a graduate student in the Bernardi group. And today Sergei and I will be talking about PerturboPy, a Python suite for post-processing and testing for Perturbo. So here's a brief outline. We will be talking about in detail how to install PerturboPy, as well as the API and general code structure. We'll be listing all of the post-processing features available, and then Sergey will be explaining how the test suite works, as well as the automatic input generation feature. So to use PerturboPy, we suggest using it within a Python virtual environment. So we can create and activate this using Anaconda. So we have the commands shown here. So you would type in your terminal conda, assuming you have Python installed, conda create PerturboPy, which is the name and the version of Python. And then to activate the virtual environment, you type conda activate PerturboPy. And then now you're inside the virtual environment called PerturboPy. And you can test it's working by typing Python and checking the version. So we would see Python 3.10, which is what we specified initially. So the installation of PerturboPy is very straightforward. There are two methods. The first method is the one that we recommend, which is using PyPI. So while inside the virtual environment, we install PerturboPy using pip, which is the Python package manager. So we've repeated the commands to create the virtual environment here. So you'd have your virtual environment activated, and then all you do is type pip install PerturboPy, and that's it. And then PerturboPy is installed. The second method is cloning the GitHub repository. So we would go to PerturboPy, which is a public GitHub repo, and you can go to the code button, the green code button on the website, and just type git clone and the URL, or you could download the zip file. That's another way you could install it. And then you would navigate to the folder that you just cloned and install it with pip. So pip install dot, assuming you're inside that folder. And you've installed PerturboPy. So now we'll be talking about the general code structure of PerturboPy. There are three main features, one of which is the post-processing, the input generation or generate input, and then the testing suite. So for the post-processing, we have the calc modes feature, which is divided into several different classes, one for each available calc mode. So for example, we have the phonon dispersion class, the bands class, trans, and more. Within the bands class, there are several methods available for you to analyze the data. So plot bands to help plot the bands, direct band gap, and many more. These methods are discussed in depth on the website shown at the bottom here. So the general workflow of using PerturboPy is first we would run calculations using Perturbo, which then generates a YAML file. So all of the calc modes in Perturbo generate a YAML file, and the calc modes that are supported by PerturboPy then take this YAML file and reads it, and we can analyze the data with it. So on the bottom here, we have an example with a bands calculation. So we're using like an interactive mode. So we would import our post-processing PerturboPy package, and then we would import the data from the YAML file. So we are creating a bands object with the YAML file as the input. And we can access the data through the object attributes. So for example, silicon bands dot bands would give us the information for the 8th band. We can also use the various methods within that class, such as direct band gap, to analyze the data. So here we're calling on the direct band gap method to calculate the direct band gap between the 4th and 5th bands. So there are many supported calculations, and we are continuing to update PerturboPy as we update Perturbo. Some of the supported calculations are bands, phonon dispersion, FMAT or electron phonon matrices, transport, imaginary self-energy, dynamics run, and more. And there are a lot of in-depth tutorials on the PerturboPy website, which we will go through towards the end of this talk.
Okay, so the next two important parts of the PerturboPy is the test suite, which you talked briefly earlier, and the input generation. So let's start from the input generation because it's like a bit more simple. So basically, for each computation mode, you have the input file, which you need to fill in. And in case of each computation mode, it requires different set of the mandatory and optional parameters, which you don't know by like, you don't know before the actual before reading about these calculation modes. And in order to simplify work with each computational mode, we have this interactive workflow, which I shown earlier, and also the tool which called input generation, automatic input generation program, which can basically provide you with the input file for each computational mode. So basically how it works. It probably will be easier to show it on the example. So basically, if you go to the Docker container, important thing to mention is that basically inside of the Docker container, you already have installed PerturboPy. So you don't need to reinstall it second time. So yeah, we're going here. Type ls. And basically what we can run is we can run this command. So the executable itself called input generation. And then you can just like add some parameters. So the obligatory parameter is the calc mode. So it's for what type of calculation mode you want to generate the input file. In our case, it will be a calc mode which is called APH mode. So calc mode APH mode. Enter. And you see the output. File per.in is generated. And how it looks like. Let's go through it. Per.in. So we see we have the header here, so that this input file was automatically generated by PerturboPy, date, and we have some parameters. So we have a set of mandatory parameters, which should be defined. So you see that like calc mode already defined. We see that we need to define prefix for calculation, name for the K and Q lists, and we can also define some optional parameters if you want. So that's all. What you should do if you wanna make more, like add more details inside of the input file, because I mean, like in many cases, in all cases, you basically need to add more details. You have some obligatory parameters which you need to fill in. For this case, you can use more fancy, like more parameters for this input generation. So for example, here we can copy this command. So we can type input generation, calculation mode, or also option C, APH mode, with the prefix SE and the minimum band equal to 10. Let's just type enter. We see that this file is generated as well. And let's open it second time. What we will see is that we have here already defined calculation mode. We have prefix. We have minimum band. So this parameter is defined. And the same way you can define any parameter inside of your calculation mode. You also can define FK list name, FQ list name, frequency cutoff, everything, like all parameters for each type of calculation mode which you have, which could be very helpful when you start working with Perturbo and when you don't know exactly what type of how exactly should looks like the input file. So that's on the input generation. And now let's go back to the presentation and talk about the test suite for Perturbo. So basically, the general idea is that we splitted the tests into two parts. First one is the test cases. So it's basically like reference files which we compare our calculation. This test files, this reference file saved in the Perturbo folder itself. So you're able to find them in the Perturbo folder in the folder tests. Second part is the test code. So it's basically like all of the logic, how to run the tests, how to compare results, and it's inside of the PerturboPy. So What's the general idea of a test suite? Basically, we have reference calculations of which we obtained with usage of Perturbo-code. On our machine, we made these calculations. We're sure that these calculations are right. We're sure that results are correct. Everything is good. We can obtain from this like reference ID of Perturbo-code or Qt-Perturbo-code, we can obtain the YAML and H5 file. When we run tests, so like after it on a new machine for a new compilation for I don't know new version of the code, if they add some changes inside of the code and we want to understand is it correct or not, we obtain new set of the files and then we can just directly compare them. And if the difference is smaller than the tolerance, then everything is good, tests are passed, we are going good. If the tolerance is smaller than the difference between the files, then it means like something is wrong with our calculation, or like if it's also not able to produce the output files, all the output files has the incorrect format or some other type of errors, our program is able to capture all of these issues and show them in pretty high details, like and explain what was the problem. For basic run tests, we basically can follow the procedure which I described already during the previous hands-on session. You go to the folder with the tests. So yeah, basically we can just, in case of our container, we go to the optional Quantum Express Perturbo tests. CD, sorry, my bad. CD. And yeah, here you have all of the information on the tests. And what we have here, we have file test listing.yaml, which basically just define what tests you should run. So basically just the name of them. Input files, so it means like all of the details of like what procedure should be run. So it's like what type of computation mode should be run, like what the input of it and so on. You have the reference files, so it's basically what files with which we compare our results, and some our supplementary files. And the folder which is called config machine, we can see what's there. Yeah, here you see lots of different files. So basically all of these files are for different cases. So basically like this is the file which you used previously. It's basically the configurational file for a case when you just need to test the Perturbo-code. This one is that you need to, if you want to test both Qt-Perturbo-code and Perturbo-code. This one is for a case of the serial running. This one for a case of the MPA runs. What's inside of these files? Each of them looks pretty similar. So basically they have parameter code per.scratch. It's the name of the folder inside of the test folder where you save all the temporary files while you're running the tests. Also, if some tests are failed, you're able to find information on the tests inside of this folder TMP. And you have the subsection here which is called computational info. Here you see it like before the running of the Perturbo-code, you need load the module Perturbo, define the parameters for the OpenMP, and run Perturbo-code in this way. So for our case, as I said, the config machine will looks like this. Config machine.yaml. It will, oops, my bad. It will looks, yeah. Let's copy it. Config machine Perturbo. Config machine.yaml. Yeah, and let's go through it. YAML. What we see here is that, yeah, basically we don't need to download the package just because it's already downloaded by itself. And you don't need this parameters as run and all. And it looks just like this, basically. And this will be enough to run your tests inside of the Docker container. And then you just like type the run tests if you want to run just the tests for the Perturbo-code. What will be if you also want to check the executable Qt-Perturbo-code? Because as we said, Qt-Perturbo-code is the core executable which help us to obtain the APR files, which are most important file in the Perturbo world. In order to do it, you basically need to run the additional command, run Qt-Pert, and it will also run the tests for the Qt-Perturbo-code. Why we do not run them automatically? There are several reasons. First one, Qt-Perturbo-code basically can take pretty long time to go. So it's just additional tests and it will require some time. Second thing is that, as we said, qtpr.x require supplementary files from the quantum expressor, which could be pretty heavy by themselves. So basically, for the set of the tests which you have right now, these supplementary files, I think, take from 1 to 2 gigabytes, which is pretty heavy. That's why we do not share them when you download the Perturbo or PerturboPy, and they download on the fly during the running the tests. So basically, how it will look like, if you type this inside of your Docker container, yeah, so what we should do if you want to run this type of a test, we need to define, we need to copy different file, qtpr.yaml, with this name, and let's check it, figmachine.yaml. Here we have in computational info already details for running the both qtpr.x and perturbo.x. And you have also parameter which called source link. It's exactly a link for for the cloud storage from which you need to download from which the machine will automatically download the supplementary files which you obtain from a Quantum Express. So yeah, just do not change this parameter because it's defined by us already. This is the preliminary comments which should be run like before all the tests, and also preliminary comments for the OpenMP. So yeah, we can modify this, so we don't need to download this. We can adjust this parameter. And yeah, adjust this and also delete and pulse as well. This one and this one. Good. Okay. Now we run the command, which is shown in the slide. So basically run qtpert with the option S, just to see what's going on during the test. And if you run it, you see what like it downloading the zip archive, which as I told can be pretty heavy. So it's like it will take some time just in order to obtain the data on these preliminary calculations. Then it automatically run perturbo.x tests. It will compute all of the APR files with usage qtpr.x, and then on the base of these new APR files, it will run perturbo.x second time. So instead of the comparing APR files by themselves, we compare the actual physical characteristics which we obtain on the base of these APR files. So it will take some time. It will run lots of additional tests. So yeah, I mean, it's if you install the package and you're like, for you, it's very important to see that like APR files producing clearly and accurately. It's pretty good to run the full test, but when you develop already, if you develop the code or add some changes by yourself, most probably you will do it inside of Perturbo.x for Perturbo.x executable. So APR files, qtpr.x will be unchanged. So it's fine to like in many cases just fine to run the test for Perturbo.x. Yeah, this test will take some time. So
in the meantime, we'll show the website.
yeah, in the meantime, we can show the website. That's true.
Slides for and the box.
Yeah, you can find on the books, hands-on too. Yeah, exactly.
I see. We can resend. It should be in hands-on to folder. There's no hands-on to.
On the box?
Yeah, it's missing. Oh wait, this is the GitHub. Let me get out there.
Yeah. So how looks the website? PerturboPy? Yeah, done. Yeah, okay. So basically, the website of PerturboPy looks like this. So here you have all of the tutorials on it. So basically, general usage of it. So installation procedure and the running the virtual environment. Lots of tutorials on the post-processing. So basically, inside of the tutorials, you can find all of the tutorials for each separate computational mode. So for each of the computational mode, which is you're able to use inside of PerturboPy, you'll be able to find like pretty detailed tutorial, for example, like for each mod. You see how to access the data and how to make the related plots. Also, we have very detailed tutorial for test suite, like all of the possible options for it, because I mean, like, basically test suite has lots of additional parameters. For example, you can define the source folder from which you need to take the tests, the text for tests. So for example, you wanna check only the tests which is related to the transport, or some tests related to the spins, so some computational modes related to the spins. So like, or you want to run like only some type of the APR file. So for example, you want to check only 2D systems or only 3D systems. Like you can exclude some tests if you want. You can just define the test name, so you can define exactly the name of the test which you want to check. So if you had some fail and then you change the code, you can not run like the full test suite, only one test. Run Qt option, which I discussed previously. So it's like, tell what you need to run the Qt test as well. Config machine option, if you want to use some like different name for YAML file, you can define this parameter. And these two option pretty important. So keep Perturbo or keep APR files. So basically it tells the machine, even if you pass the tests and everything will be good, please save the files, like output files, which you obtained. If you do not pass this option, then it will just automatically delete all the testing files just in order to keep memory clean. And the last option is the architecture or arc. Basically, because we can compile Perturbo for the two types of a system, for a CPU or for a GPU, we want to run the tests also for two types of the systems. And that's architecture just basically tell you want to run CPU or GPU. And like for GPU tests, you're able to run several tests. And for the CPU as well, you can like run the full set of tests. And also here, like you're able to see how to make the new tests if you want to do it by yourself. Also here see the input generation tutorial, which is pretty short for obvious reason, because I mean, like input generation is pretty clear to how to use. And the API for the PerturboPy, where you can find all of the details for each command and each option of PerturboPy with all the details.
So if you're curious about like the inputs on certain of the methods, you can go to postprocessing.calcmodes, navigate to your desired class, and then we click the bands class and we see all of the available methods for the bands class, as well as the input parameters. While we don't have a folder on the GitHub for the hands-on 2, I guess hands-on is installing PerturboPy, and in the remainder of the hands-on tutorials, we will be using PerturboPy. So you will get a chance to use PerturboPy throughout the workshop.
And we can return to the test folder because we see it all passed and everything is good. So this means that like, yeah, everything works. And yeah, that's exactly what I told about. The test will automatically remove all of the folders if the tests are passed. If they are not passed, it will save some temporary files and you'll be able to see exactly what's the difference and where you have the issues. Yeah, so I think that's all what we wanted to say on the PerturboPy. Feel free to ask some questions if you have. Thank you.